All right, let's take a look at our practice test. We're told to solve each inequality. And for the first problem, we have x minus 7 over x minus 1, then plus 5, and this is greater than 0. All right, so the idea with this type of problem is your first step is you're going to get a single rational expression on the left-hand side. You want your inequality symbol. In this case, it's a greater than, but it could be a greater than or equal to, a less than, or a less than or equal to. And then you want 0 on the right-hand side. Okay, so what I'm going to do here is just get a common denominator, and x minus 1 would be that common denominator. So I would say x minus 7 over x minus 1, then plus you have your 5 multiplied by this quantity x minus 1. Make sure to use parentheses there. Then this is over. Down here, I'll just put x minus 1. No need for parentheses in that case. So we'll say this is strictly greater than 0. And from here, I'll just say this is x minus 7. Then plus, you'll have 5 times x, which is 5x. And then basically 5 times negative 1 is minus 5. This is over the common denominator of x minus 1. And then this is greater than 0. I'm going to simplify in the numerator. So x plus 5x would be 6x. Then negative 7 minus 5 is negative 12. And this is over x minus 1. So then this guy is greater than 0. All right, so once you get it to the point where there's a single rational expression on the left, and then again, you must have your inequality symbol and then 0 on the right. What you want to do is you want to set your numerator equal to 0. You want to solve that equation. And then you want to set your denominator equal to 0. You want to solve that equation. Now remember, because we're working with a rational expression, when you set your denominator equal to 0 and you solve that, that is going to give you the value or the values that must be excluded, right? Because you can't divide by 0. So that's very important. So I'm going to set 6x minus 12 equal to 0. Let's solve this equation. We'll add 12 to both sides. We'll cancel this, and we'll say 6x is equal to 12. Divide both sides of the equation by 6. We'll cancel this, and we'll go ahead and say that x is going to be equal to 2. Okay, so that's one critical value. Now the other one is going to be x minus 1 is equal to 0. Add 1 to both sides. We'll cancel this. So we get x is equal to 1. But again, we must remember in this case that this value of 1 is going to result in division by 0, right? So if you wanted to, you can make yourself a little note and say that this is the set of all x such that x is not going to be equal to 1. So that's pretty important. You could even write out that this is going to be your domain just to make that crystal clear. Okay, once you have all that information, you're going to go to a number line, or again, a lot of people will use a table. And then essentially, you're just going to look at x equals 1, which is right here. So let me put a little vertical line there. And then we had x equals 2. So let's put a vertical line there. And you're just splitting the number line up into regions or intervals. So let's say this is a, so that's anything that's less than 1. Let's say this is b, so that's between 1 and 2. And let's say this is c, that's anything greater than 2. So you just have to test inside of each, and then you'll consider the 1 and 2 separately. We already know that 1 has to be excluded, but we'll think about 2 separately. Okay, so let's plug in. We're going to have, and you could factor this and say this is 6 times the quantity x minus 2 over your x minus 1. Is this greater than 0? So just pick something that's in region A, and let's write this out. So A, B, and C. So in region A, I could pick 0. So if I plugged in a 0 there, 0 minus 2 would be negative 2. So you'd have 6 times negative 2, which would be negative 12. So essentially, let me write this over here. We'd have negative 12, and this would be over. You would have 0 minus 1, which is negative 1. Is this greater than 0? Well, remember, without even doing the division, a negative over a negative is positive, and a positive is always greater than 0. But you could also just say this is negative 12 over negative 1, which is positive 12. And of course, that's greater than 0. So here, this is going to be true. Now for region B, again, just pick something between 1 and 2. I think an easy one would be maybe 1.5. But again, if you just plug that in, this guy right here, you see that if you plugged in a 1.5 and you subtract away 2, you're going to get negative 0.5, right? But just think about it this way. You'd have a negative here times a positive, so that's negative. And then down here, you'd have a positive. So negative over positive would be negative. So a negative is not going to be greater than 0. So this one is false. Okay. And just for completeness, in case you're lost, if you did 1.5 minus 2, you would get negative 0.5 or negative a half. If you multiplied by 6, you would get negative 3. And this would be over your 1.5 minus 1, which would be 0.5 or half. Let me just write 0.5 here. And negative 3 divided by 0.5 is going to be negative 6. So this would be negative 6 is greater than 0, which again is a false statement. All right, then for C, let's just pick 3. So if you plugged in a 3 there and a 3 there, 3 minus 2 is 1. 1 times 6 is 6 over 3 minus 1 would be 2. 6 divided by 2 is 3. So again, you can think about this as 3 or just the fact that it's positive. That is going to be greater than 0. So this guy is going to be true. So to put our solution together, we know that things in region A work. So anything that's less than 1, so x is less than 1, then or, we know that things in C are going to work, so anything greater than 2. But let's consider the fact that 2 and 1 are both going to be excluded. 1, because again, you would violate the domain there. X cannot be 1. We know that gives us division by 0. But for 2, remember that would result in this guy right here, this left-hand side being 0. So you're going to get 0 is greater than 0, which is a false statement. So this would be our solution. So in interval notation, we would say x is less than 1. So from negative infinity up to and excluding 1. So you have a parenthesis next to each, and it's the union with basically anything greater than 2. So you have a parenthesis next to 2, and then out to positive infinity here. Okay, so graphically, if you want to do this, you can go to your number line, and here's 1. I'm going to put a parenthesis facing to the left. Again, you can use an open circle just to show that 1 is excluded. And then I'm going to shade everything to the left here. And then I'm going to go to 2, and I'm going to put a parenthesis facing to the right. Again, you can use an open circle if you want. And I'm going to shade everything to the right. All right, let's take a look at problem number 2 now. So we have x plus 5 over x minus 4, then minus 1, and this is less than 0. So again, I want to make this left-hand side here into a single rational expression. So we have x plus 5, then over x minus 4, and then minus, we have this 1. So I'm going to multiply this by this x minus 4 over x minus 4. So you basically just have this x minus 4 up here over x minus 4 down here. And again, that's because 1 times anything is just itself. Then this is less than 0. Now you do need to be a bit careful here. You are subtracting this whole thing away. So when you set this up, go x plus 5, and then minus, I'm going to wrap this in parentheses. So this x minus 4 here, because again, the x is being subtracted away, and so is the negative 4. So that's very important. Then this is over your common denominator of x minus 4. And again, this is less than 0. We're going to have x plus 5, and then this negative is going to get distributed to each. So this is minus x, and then this is plus 4. And again, this is over this x minus 4, and this is less than 0. So x minus x is going to be 0. So essentially, you just have 5 plus 4, which is 9, over this x minus 4 here, and this is less than 0. So for these, the next step is to set the numerator equal to 0, solve that, and then set the denominator equal to 0 and solve that. In this particular case, we can't really set 9 equal to 0. That doesn't make any sense. There's no variable there. So you only have to set the denominator here, x minus 4 equal to 0. So let's say x minus 4 is equal to 0. We would add 4 to both sides and just get that x is equal to 4. Now we should note that this value of 4, if I plug that in for x, that gives me division by 0, right? So we can't divide by 0. That's undefined. So I'm just going to put a note here that my domain is the set of all x such that x is not equal to 4. So again, coming to the number line, let me put a vertical line at 4. So you're just going to have 2 regions here. So anything less than 4, let's call that A. And then anything greater than 4, let's call that B. So you have A and you have B. So just pick something in A. I would pick 0. If you plugged in a 0 here, 0 minus 4 is negative 4. So you would have 9 over negative 4. It's just a negative value, and that's always going to be less than 0. So this is going to be true. Then for B, you could pick something like, let's say 5. 5 minus 4 is 1. So you'd have basically 9 there, or a positive value, which is not going to be less than 0. So this is going to be false. Okay, so for this one, again, 4 is excluded, right? It violates the domain because we specifically said here that x can't be 4. That gives us division by 0. So for the solution, x would need to be strictly less than 4. All right, so coming back in interval notation, we'll say from negative infinity up to and excluding 4. And again, use a parenthesis next to 4 because it's excluded. And then graphically, I'm just going to put a parenthesis at 4, or again, if you want to use an open circle, that's fine. And then I'm going to shade everything to the left. All right, let's take a look at problem number 3 now. So we have x plus 6 over x minus 5. This is greater than 1. So let's write x plus 6 over x minus 5. I'm going to subtract 1 away from each side of the inequality. So you'd have minus 1 over here. And now this is greater than 0. So the idea here is to get this into one single rational expression. So what I'll do is say this is x plus 6 over x minus 5. And then minus, I'm going to multiply 1 by this x minus 5 over x minus 5, which would just give me x minus 5 over x minus 5. Then this is greater than 0. So just like in our last example, we want to make sure that we use parentheses here. So we have x plus 6 and then minus this whole quantity here. So this x minus 5, this would be over the common denominator of x minus 5, and this is greater than 0. Okay, so you're going to have x plus 6, then you'd have minus x, and then you'd have plus 5, and this is over your x minus 5, and this is greater than 0. So basically, x minus x is 0, so that's going to disappear. You just have 6 plus 5, which is 11. So we'll say this is 11 over this x minus 5, and this is greater than 0. So again, when you get something like this, you just set your denominator here equal to 0. So you say x minus 5 is equal to 0. When you solve that, you get x is equal to 5. Now, I want to note here again that your domain is going to be the set of all x such that x is not going to be 5, right? It can't be this value because if you plug a 5 in for x, you're dividing by 0, and that's undefined. So coming to the number line, let's look at 5. We'll put a little vertical line there. And essentially, I just want to test on the left side of 5 and the right side of 5. So let's call this A, anything less than 5, and let's call this B, anything greater than 5. And so for A, let's just use 0. You'd have 11 over 0 minus 5 is negative 5. So positive over negative would be negative, and that's not greater than 0. So A, this would be false, right? Nothing's going to work in A. Then for B, let's plug in 6. So you'd have 11 over, you have 6 minus 5, which is 1. So again, that would just be 11 or a positive value, and that's going to be greater than 0, so this is true. So 5 is excluded, right? Because again, that violates the domain. So we would just say that x here has to be greater than 5. So for interval notation, I'll put a parenthesis next to 5 because 5 is not included. And then we'll put this out to positive infinity. And then graphically, let me put a parenthesis at 5, and then I'm going to shade everything to the right. Again, if you want, you can use an open circle there just to show that 5 is excluded. All right, let's take a look at problem number 4. So we're going to have 5 over x minus 1. This is greater than, we have 8 over 2x plus 7. Again, the idea is to have a single rational expression on the left, and then your inequality symbol and 0 on the right. So I'm just going to subtract this guy right here away from both sides of the inequality. So I'm going to say this is 5 over x minus 1, then minus this 8 over 2x plus 7. And I'll keep my greater than symbol, and this is going to be a 0 now. Okay, from here I need to get a common denominator. So the LCD would be x minus 1, this quantity, times the quantity 2x plus 7, because there's nothing in common between those two denominators. So we'll say this is 5 over x minus 1, and this is multiplied by this 2x plus 7 over 2x plus 7. Let me wrap this, and I'll also wrap this down here. Then we have minus, you're going to have 8 over your 2x plus 7, and then times your x minus 1 over your x minus 1. So let me wrap this, and then also this. Let me slide this down just a little bit, and I'll say this is greater than 0. Okay, so over here on the left, 5 times 2x is going to be 10x. And then plus 5 times 7 is 35. Then minus, I would put this inside of parentheses or brackets or something like that so you don't make a sign mistake. 8 times x is 8x. And then minus 8 times 1 is going to be 8. Let's close that down. And instead of writing the denominator, let me just clean this up real quick, and then we'll write our denominator. So basically you would have 10x plus 35. And this minus would be distributed to each. Again, you can always put this as plus negative 1 if you're struggling with that. So this is minus 8x and then plus 8. So let me actually get rid of this line right here. And we're going to say this is 10x minus 8x, which is going to be 2x. And then 35 plus 8, that's going to be 43. And so this would be over your common denominator, which is the quantity x minus 1 times the quantity 2x plus 7. Now, I would leave this in factored form because, again, you're going to have to set this equal to 0 and solve the resulting equation. So this is easier to do versus putting it into your ax squared plus bx plus c form and then have to factor it back to solve the equation. So let's say this is greater than 0. Okay, from here, I'm going to take my numerator, which is 2x plus 43. I'm going to set that equal to 0. I'm going to solve that. So let's subtract 43 away from each side of the equation. We'll cancel this. We'll get 2x is equal to negative 43. Divide both sides of the equation by 2. We'll cancel this. And we'll say over here that x is equal to, we'll have negative 43 over 2. So that's one critical value, and this one's from the numerator. Okay, for the denominator, we're going to get 2. Okay, so we need to say x minus 1, this factor here, set that equal to 0. We would solve that and say that basically x is equal to 1, right? Just add 1 to both sides. Then the other one would be 2x plus 7 is equal to 0. Subtract 7 away from each side, cancel this. We get 2x is equal to negative 7. Divide both sides of the equation by 2, cancel this. So then also we get this negative 7 halves. Okay, it's very important to list these guys here and to keep track of the fact that these came from setting your denominator equal to 0. So we know that we can't plug in a 1 or also a negative 7 halves because we'd be dividing by 0. And again, that's undefined. So I'm just going to write this out formally. Again, if you're just doing this on your own, you don't need to. So the domain is the set of all x such that x is not equal to this 1 or this negative 7 halves. Okay, so coming to the number line here, we don't have a typical number line because these values are just too big for me to put them in. But essentially, you have negative 43 over 2. That's the leftmost value on the number line. It's negative 21.5 as a decimal. So I'm just going to put that here. So negative 43 over 2 in the leftmost position. And then you would have negative 7 halves. That's negative 3.5. Let's put that in the middle. And then you're going to have this positive 1. So let's put that right there. So essentially, I'm just going to test inside of each interval. So let's just say this is A. So that's anything less than negative 43 over 2. This is B, that's anything between negative 43 over 2 and negative 7 halves. This is C, that's anything between negative 7 halves and 1. And this is D, that's anything greater than 1. To get some room, I'm going to get rid of these. I think we know what we have here. And we also know this is a strict inequality here. So if we think about negative 43 over 2, negative 7 halves, or 1, those are all going to be excluded. Okay, so we can just determine that now. All right, so let me just write out that we have A, we have B, we have C, and we have D. And we just need a test inside, and this is going to get quite tedious. So anything less than negative 43 over 2, you could just pick negative 22. So let's check that. We'll have 2 times negative 22, then plus 43. This would be over. You're going to have negative 22 minus 1. And then you'll have this guy 2 times negative 22, then plus 7. Now, 2 times negative 22 is negative 44, and then negative 44 plus 43 is going to be negative 1. So I'm just going to erase this and put negative 1. But the key thing here is it's going to be negative. Then down here, negative 22 minus 1 is going to be negative 23. So this is negative 23. And then here, 2 times negative 22, we know that's negative 44. And if we add negative 44 plus 7, that's going to be negative 37. Now, you can go through and do the calculation for completeness, but at this point, if we're asking if this is greater than 0, we know it's going to be false, right? Because negative times negative is positive, and then you have a negative over a positive, which is negative, and a negative is not greater than 0. But just for the sake of completeness, negative 23 times negative 37, that's 851. So this ends up being negative 1 over 851, and again, that's not greater than 0. So coming back here, things in A don't work, so I'm just going to say this is false. Okay, so for B, you have between negative 43 over 2 and negative 7 halves. So I'm just going to pick negative 4. So you would have 2 times negative 4 plus 43. This is over. You have negative 4 minus 1, which is negative 5. And then over here, 2 times negative 4 is negative 8. And then negative 8 plus 7 is going to be negative 1. So this up here is going to be a positive, right? I think we can see that. And down here, this is going to be a positive. So you'd have a positive over a positive, which is going to be a positive. So without going through and cranking this out, you can say this is true, right? A positive is greater than 0. But for completeness, just in case you want to see it, 2 times negative 4 is negative 8, and negative 8 plus 43, that's 35. And then negative 5 times negative 1 is 5. So this would be 35 over 5, which is 7. And of course, 7 is greater than 0. So we'll come back here and say this is true. And then for C, we have between -7/2 and 1. So I would just pick 0. And this is really easy to do. So this is gone. So you have positive 43 here. And let me just write that. And this is over. We'll have 0 minus 1, which is -1. And then 2 times 0 is 0. So you just have 7 there. And essentially, this is going to be negative, right? So essentially, you would have 43 over -7. That's a negative 43 over 7. That's not greater than 0. So this is going to be false. Okay, then lastly for D, you just need to pick something that's greater than 1. Let's just pick 2. So you'd have 2 times 2 plus 43 over 2 minus 1 is 1. Then times 2 times 2 is 4 plus 7 is 11. Again, without going through and cranking this out, you know this is going to be greater than 0 because you're going to have a positive over a positive, and that's always greater than 0. So let's just say this is true. In case you're curious, 2 times 2 is 4. 4 plus 43 is 47. So this would be 47 over 11. And of course, that is greater than 0. So for the solution, we know nothing in A works. In B, we're working here. So basically, x is greater than -43/2 and less than -7/2. C, nothing works again, and then D, things work. So I'm going to put or here, x is greater than 1. Now, we already said that these critical values are all excluded because this is a strict inequality, and then also x can't be 1 and x can't be -7/2 because we get division by 0. Okay, looking at this, let's put this in interval notation. So I'm going to put a parenthesis, so -43 over 2, this is not included. And then this goes up to and does not include -7/2, so another parenthesis. And the union with anything greater than 1, so a parenthesis, and then out to positive infinity. So graphically, let's put a parenthesis here, or again, you can use an open circle, and then a parenthesis here, and then I'm just going to shade everything in between, and then I'll put a parenthesis here, and then shade everything to the right. So basically, x can be anything that's greater than -43 over 2, which is -21.5, going up to and excluding -7/2, which is -3.5, and then, or it could be any number that's greater than 1. All right, let's take a look at problem number 5 now. So we have 3 over x plus 2 is less than or equal to 4 over x minus 9. So again, I want one single rational expression on the left. I want an inequality symbol, and then I want 0 on the right. So let's say this is 3 over x plus 2. I'm going to subtract this guy away from both sides of the inequality. So minus 4 over x minus 9. This is less than or equal to 0. Okay, so let's get a common denominator going. This denominator is x plus 2. This denominator is x minus 9, so there's nothing in common. So I'm just going to say this is 3 over x plus 2, and then times this x minus 9 over x minus 9. I'm just going to wrap everything for clarity like this, and then minus, you have this 4 over x minus 9. Let me just wrap that now, and then times, you're going to have this x plus 2 over this x plus 2. Let's wrap that and wrap that. This is less than or equal to 0. Okay, so from here, I'm going to have 3 times x, which is 3x, and then minus 3 times 9 is 27. Now you have a minus sign here, so make sure you put some brackets or parentheses or whatever you want to use. You just don't want to make a sign mistake. The whole thing is being subtracted away. So you're going to have 4 times x, which is 4x, and then plus 4 times 2, which is 8. Now, I'm just going to distribute this to each. And again, you can always say this is plus -1 here and distribute that like that. So this is -4x and then minus 8. Let me get rid of this and drag this up here. And then basically 3x minus 4x is -x. -27 minus 8, that's going to be -35. Let me get rid of this. Let's put this over our denominator. Again, we're going to leave this in factored form. So x plus 2, this quantity times the quantity x minus 9. And this is less than or equal to 0. All right, at this point, I'm going to set the numerator equal to 0. So -x minus 35 is equal to 0. We could just add x to both sides and say -35 is equal to x. Or you could just flip that around and say that x is equal to -35, like this. Let me make this 5 a little bit better. Then we want to set the denominator equal to 0. So we have x plus 2, then times this x minus 9. This is equal to 0. So x plus 2 equals 0. Here, x would be -2. So let's put x is equal to -2. And then the other one would be, you have x minus 9 is equal to 0. So there, x would be 9. So again, I want to specifically notate that x cannot be -2 because it would result in division by 0. And then x cannot be 9 because, again, it would result in division by 0. So these two would need to be excluded from the domain. So let's just say our domain is the set of all x such that x is not equal to -2 or 9. So coming back here, let's think about the critical values. You have -35. That's going to be the furthest to the left on this number line. Then you have -2. That's going to be in the middle. And then you have +9. Okay, you can get rid of this now. You don't need these anymore. And just keep your domain here just so you know what's going to be excluded. And then you're just going to set up some intervals. So this is A, anything less than -35. This is B, between -35 and -2. This is C, between -2 and 9. And this is D, which is greater than 9. So what I'll say here is that we have A, B, C, and D. Okay, let's test something in A. Let's test maybe -36. So you would have, and you have to be careful here, the negative of -36, then -35. And this would be over. You have -36 plus 2. That quantity times the quantity -36 minus 9. Is this less than or equal to 0? So the negative of -36 is 36. So this is 36 minus 35, which is 1. Down here, we know that this is a negative and this is a negative, and a negative times a negative is a positive. So you would have a positive over a positive, which is not less than 0 and not equal to 0. For completeness, in case you want to know, this would be -34, right? If you did -36 plus 2, that's -34. And then -36 minus 9, that's -45. And if you multiply these two together, you get 1,530. But again, the key thing here is that this is positive and it's not less than 0 and it's not equal to 0. So for interval A, let's just say that things are not going to work. So we'll just put false here. And then for B, let's just pick something like -3. So we'll have the negative of -3, then -35, and this is over. You would have -3 plus 2, that's going to be -1. And then -3 minus 9 is -12. So we know that the negative of -3 is 3, and that 3 minus 35 is -32. So we can see that this guy is going to be a negative, right? You have a negative over a positive. So what ends up happening is this will be less than 0. And again, for completeness, -1 times -12 is +12. And so if you had -32 over 12, you could divide each by 4 and say this is -8 over 3. So you get -8 over 3, which again is less than 0. So this is going to be true. Okay, for C, I would pick 0. And so the negative of 0 is 0, so you just have -35 in your numerator. In the denominator, you would have 0 plus 2, which is 2. And then times 0 minus 9 would be -9. So is this less than or equal to 0? Again, you can just see immediately this is going to be a positive because you have a negative over, this would be -18 down here. And essentially a negative over a negative is positive. So you have 35 over 18. That's not going to be less than 0, and it's certainly not equal to 0. So this is going to be false. All right, then for region D, we can pick 10. All right, so let's just plug in a 10 here and here and here. And we just have to be really careful. We have the negative of 10, so this is -10, then -35. This is over. This is 10 that's being plugged in. So it's 10 plus 2, that's 12. And then here, 10 minus 9 is going to be 1. So is this less than or equal to 0? Well, -10 minus 35, that's going to be -45. So this is -45. And this is over 12 times 1, which is just 12. Now, just looking at the sign, we know it's going to be negative, right? And a negative is always going to be less than 0, so this would be true. For the sake of completeness, if you just want to reduce this, well, -45 would be divisible by 3. This is basically -15. And 12 is divisible by 3. This is 4. So this is -15 over 4 if you want to calculate it. And of course, that's still less than 0. So this is a true statement. So we can say that this one is true. Okay, so let's put our solution together here. So things in B would work. So this is where x is greater than this -35 and less than -2. And then also things in D work. So I'm going to put or x is greater than 9. Now here's where we have to be really careful. Again, we have a non-strict inequality here. So the values for x that make the numerator 0, those would be included. Okay, but we still have to exclude the values for x that make the denominator 0 because that's where we're undefined. So that's why I listed the domain here. Typically, if you're doing scratch work, you don't need to go that far. But just know that -2 and 9 would be excluded, right? So -2 is going to be excluded and 9 is going to be excluded. But -35 is okay, right? That's the value that makes the numerator 0, right? So you'd have 0 is less than or equal to 0, which is a true statement. So I'm going to make this right here as a less than or equal to. Okay, so in interval notation, I'm going to put a bracket here next to negative 35. And this goes up to but excludes negative 2. So you want a parenthesis there because, again, negative 2 would be excluded from the domain. And then the union with anything that's greater than 9. So again, 9 is not included. That's excluded from the domain. And this goes out to positive infinity. All right, so graphically, let me just say negative 35 is included. So you can put a bracket here facing to the right, or you can put a filled in circle if you want. That shows inclusion. And then for negative 2, that's excluded, right? So I'm going to use a parenthesis, or you could use an open circle. And I'm just going to shade everything in between there. And then for 9, that's excluded, so I'm going to use a parenthesis, or again, an open circle. And maybe let's use a different color there. That didn't show up so well. So let's put our parenthesis here again, and then I'm just going to shade everything to the right. So x here can be negative 35. That's okay. And then anything going up to and excluding negative 2. And then x could also be anything that's greater than 9. All right, let's take a look at problem number 6 now. So we have x squared plus 4x minus 21. This is over x squared minus 6x plus 9, and this is greater than 0. Okay, what I would do here, since I already have a single rational expression on the left, I have my inequality symbol, which is a greater than, and then I have 0 on the right. I would factor everything here. So this x squared plus 4x minus 21, you need two integers whose sum is 4 and whose product is negative 21. So that's going to be positive 7 and negative 3. So let's say this is x plus 7 times x minus 3. Then down here, if you wanted to factor this, you would notice that it's a perfect square trinomial. And what that means is that it can be factored into a binomial squared. So this is x minus 3, quantity squared. But what I'm going to actually do is say this is x minus 3 times x minus 3. And we're going to cancel something in a moment. So let's say this is greater than 0. Now, when you work with a rational expression, remember, before you cancel anything, you have to think about what is the domain. That domain carries over to the simplified rational expression. In this case, it's not going to matter because you have x minus 3 quantity squared. But essentially, you would want to set this x minus 3 quantity squared equal to 0. And you would want to solve this resulting equation. So this would only be true where x minus 3 is equal to 0, and that's where x is equal to 3. So let me actually write this off to the side so that we have it. I'm just going to say that the domain is going to be the set of all x such that x is not, let me slide this down just a little bit, this 3 here. Let me make that better. Okay, let me close this down. So essentially, if you plugged in a 3, either here or here, 3 minus 3 is 0. And again, you can't divide by 0, right? That's undefined. So now that I've done this, what you can do is cancel this with this. So that's out of the way. And so I'm going to rewrite this as x plus 7 over x minus 3. And this is greater than 0. Now, I just want to note, in this case, the domain didn't change between this guy and the simplified form. But if you do this, in some cases, it might change. You have to keep the domain from the original rational expression, okay? Because it carries over to the new guy that you're working with. That's very, very important. So now, what I would do is just take x plus 7 and set that equal to 0. So let's say that we have x is equal to negative 7, and I'm also going to use this x is equal to 3 here, because we need the values for x that make the numerator 0, which is negative 7, or the denominator 0, which in this case is 3. All right, so let's find negative 7. So that's going to be right there. And then let's find 3. So that's going to be right there. You can actually get rid of this at this point. This is a strict inequality. So we know that negative 7 is not going to work and 3 is not going to work. 3 violates the domain, right? Because x specifically can't be 3 because we'd have division by 0. And for negative 7 plus 7 is 0. So you'd have 0 is greater than 0, and that is a false statement. So let's set this up as region A, region B, and C. And A is anything less than negative 7, B is between negative 7 and 3, and C is greater than 3. So let's say that we have A, B, and C here. And let's just test inside of each. I'll drag this up a little bit. So for A, let's just pick negative 8. So negative 8 plus 7 is going to be negative 1. And then basically negative 8 minus 3 is going to be negative 11. But again, you could just think about the fact that a negative over a negative is a positive, and a positive is greater than 0. So this is going to be true. All right, for B, let's pick 0. So 0 plus 7 is 7, and then 0 minus 3 is negative 3, and a positive over a negative is a negative, and that's not greater than 0. So this is false. And then for C, let's just pick 4. 4 plus 7 is 11, and then 4 minus 3 is 1. So 11 over 1 is positive, and a positive is always greater than 0, so this is true. All right, so let me get rid of this, and we can get rid of this. We don't need this anymore. We know the critical values are excluded. I'm just going to say that x here is less than negative 7. Then we would say or. We'd say x is greater than 3. So let me put that here. We'll say x is greater than 3. So for interval notation, we'll have from negative infinity up to and excluding negative 7. So use a parenthesis there. And then the union with, again, 3 is excluded, so use a parenthesis there. So this goes out to positive infinity. So graphically, let me put a parenthesis here at negative 7. Again, you can also use an open circle if you want. Shade everything going to the left. And then at 3, put a parenthesis there or an open circle and shade everything to the right. So again, x can be anything that's less than negative 7, or x can be anything that's greater than 3. All right, let's take a look at problem number 7 now. So we have x squared plus 5x plus 4. This will be over x squared plus 5x plus 6, and this is less than 0. So again, we have a single rational expression on the left. We have our inequality symbol, which in this case is a less than, and then we have 0 on the right. So this is what we're looking for. So I'm going to factor this. In the numerator, I need two integers whose sum is 5 and whose product is 4. So that's going to be 4 and 1. So let's say this is x plus 4, this quantity, times the quantity x plus 1. This will be over. Down here, we need two integers whose sum is 5 and whose product is 6. So it's going to be 2 and 3. So we'll say this is x plus 2, this quantity times the quantity x plus 3. So nothing's going to cancel like we had in the last example. But again, if you were going to cancel something, if you get a problem like that, make sure you list your domain first, because that domain is going to carry over to the simplified rational expression. So that's extremely important. In this case, I can immediately just set the numerator equal to 0. So we can say x plus 4, this quantity times the quantity x plus 1. Let's set that equal to 0. And essentially, you say x plus 4 equals 0, that has a solution of x equals negative 4. And then if you say x plus 1 equals 0, that has a solution of x equals negative 1. Then for the denominator, let me actually just erase this part and keep this. So I'm going to put this x plus 2 here and this x plus 3 here. We'll say x is equal to, if you set x plus 2 equal to 0, it's x equals negative 2. And then if you put x plus 3 equal to 0, then it's x equals negative 3. Now again, I'm going to specifically list that negative 2 and negative 3, those are going to result in division by 0, so they need to be excluded from the domain. So let me put here that the domain is the set of all x such that x is not equal to this negative 2 or this negative 3. So coming to the number line, we have a lot of critical values, and they're pretty close together. So you have this negative 4 here, and then you have this negative 3 here, and then you have this negative 2 here, and then you're going to have this negative 1 here. Now you can actually get rid of this. Again, these two values up here, this negative 4 and this negative 1, those make the numerator 0. So you would get 0 is less than 0, which is false. So none of the critical values are going to work. So you can just get rid of it right now. And you can keep your domain there for clarity if you want, or you can get rid of it at this point. You really don't need it. So we'll just say that this is region A, so less than negative 4. This is B, between negative 4 and negative 3. This is C, between negative 3 and negative 2. This is D, between negative 2 and negative 1. And then this is E, which is greater than negative 1. So that is a lot of testing to do. So if you get something like this, just try to speed it up by just thinking about the sign. You don't need to plug it all the way in. I guess if you're using a calculator, it's not that big of a deal. But let's start with, I'm just going to erase this. We don't need this anymore. Let's start with negative 5 for interval A. So negative 5 plus 4 is going to be negative 1. And then negative 5 plus 1 is going to be negative 4. So this is positive 4 up here in the numerator. Down here, if you had negative 5 plus 2, that's negative 3. And then negative 5 plus 3 is going to be negative 2. So this is going to end up, you can just say this cancels with this, and you have a 2 up here. Negative times negative is positive. So basically you have 2/3 there. Okay, so this is 2/3. Now, is 2/3 less than 0? No, right? A positive is not less than 0. So this is going to be false. Okay, for B, again, this is a tight window, so it's between negative 4 and negative 3. You could just use negative 3.5. So negative 3.5 plus 4 is 0.5 or half. And then negative 3.5 plus 1, that's negative 2.5. And again, without multiplying this together, let's just say this is going to be a negative and just be done with it. So this is a negative over down here. If you have negative 3.5 plus 2, that's going to be a negative, right? That's going to be a negative 1.5. And then a negative 3.5 plus 3, that's going to be a negative 0.5. So negative times negative down here, this is a plus. So you have a minus over a plus, which is a minus. And so essentially you're going to have a negative, and that's going to be less than 0. So this is going to be true. All right, for C, you're between negative 2 and negative 3. So let's pick negative 2.5. So negative 2.5 plus 4 is going to be 1.5. And then negative 2.5 plus 1 is going to be negative 1.5. So this guy right here would be a positive times a negative, which would be a negative. And then down here, negative 2.5 plus 2 is a negative. It would be a negative 0.5. And then negative 2.5 plus 3 would be a positive, right? So negative basically over negative, which is positive. And a positive is not less than 0, so this is false. Okay, let's look at D. So now let's pick maybe negative 1.5 because it's between negative 2 and negative 1. So negative 1.5 plus 4 is going to be 2.5. And then negative 1.5 plus 1 is going to be negative 0.5. And again, you could just think about the sign here. It's going to be negative. With all these decimals, it's a little bit hard to do. Again, if you have a calculator, it's not that bad. So this is over down there. Negative 1.5 plus 2 would be 0.5. And then negative 1.5 plus 3 would be 1.5. So this right here would be a positive, right? So negative over positive is negative, and a negative is less than 0. So this would be true. Okay, for E, that's anything that's greater than negative 1. Let's just pick 0. So this would be 4, and then this would be 1, and then down here, this would be 2, and then this would be 3. So you can go through and say that this 4 would cancel with this 2, and this is 2. So basically 2/3. But essentially, you would say it's a positive, which is not less than 0. So this is false. All right, so looking at our solution here, we see that things in B work. So basically, where x is greater than negative 4 and less than negative 3. We see that things also work in D. So I'm going to put or. So in D, we have x is greater than negative 2. And we'll say and less than negative 1. Again, we know these critical values, negative 4, negative 3, negative 2, and negative 1. Those are all excluded. We talked about that earlier. So coming up here, let's say this is between negative 4 and negative 3. So again, you're going to use a parenthesis with each, and then the union. With this guy, it's between negative 2 and negative 1. Again, use a parenthesis with each. Coming to the number line, let's look for negative 4. Let's put a parenthesis there or an open circle, and then put a parenthesis on negative 3. Again, those are both excluded. Let's just shade everything in between. Let's come to negative 2. Let's put a parenthesis there or an open circle. Then come to negative 1. Put a parenthesis there or an open circle, and just shade everything in between. So x here can be anything that's greater than negative 4 going up to and excluding negative 3. Or it could also be anything larger than negative 2 going up to and excluding negative 1. All right, let's take a look at problem number 8 now. So we have 6 over x is greater than 6x minus 5. So for this one, let's write 6 over x, and then we will subtract 6x away from each side. So I'll say minus 6x. I'll add 5 to both sides, so I'll say plus 5. And then I'll say this is greater than 0. What I want to do is write this as one single rational expression on the left. So I need to get a common denominator. And essentially this denominator of x is what I'm going to use. Let me actually slide this down just a little bit. And let me erase this and move this over here. I'm going to multiply this by x over x. And I'm going to multiply this by x over x. So what we'll have is 6 minus x times 6x is 6x squared. And then plus 5 times x is 5x. Let me just reorder this and say this is negative 6x squared. And then we'll have plus 5x and then plus 6 like this. Let's get rid of this. And let's slide this up like this. And let's put this over our common denominator of x. And we'll say this is greater than 0. Okay, so for the numerator, let me just factor this. So I'm going to put a negative out in front. And then just write this as 6x squared minus 5x, and then minus 6 like this. If you wanted to factor this, let's go ahead and set up our parentheses here. Essentially, you could start with 6 and 1. So let's say we had a 6x here and an x here. And this is a minus sign, so I know in terms of absolute value, I'm going to be subtracting. And I'm trying to get to 5. Forget about the fact that it's negative 5. So for 6, it's 1 times 6 or it's 2 times 3. So if I put a 6 here, that would be 36. That's just going to be too big, right? And I can't put this 6 here because I'd have a common factor of 6. So that's out. So then you have 2 and 3. But the problem is I can't put a 2 here or a 3 here because I'd have a common factor of 2 or 3 depending on what I'm working with. So this is not going to work. You'd have to go to 2 and 3, okay? And then for 6, again, you couldn't put a 6 here or here because you'd have a common factor. So I would have to go to 2 and 3 and basically alternate. So I'd have to put a 3 here and a 2 here. And so I'd have to say that this right here would be 4x and this right here would be 9x. So I can actually make that work if I make this guy a plus and this guy a minus, right? So essentially what you're going to have is this 4x, and then here it's minus 9x, and negative 9x plus 4x, let's say that's going to be negative 5x. So this is what I'm looking for in terms of my factorization. So let's move this back up here, and let's say this is over x, and we're greater than 0. I'm going to set the numerator equal to 0. So we have the negative of this 2x minus 3, then this other quantity 3x plus 2. Let's set that equal to 0. So I'm going to say that 2x minus 3 is equal to 0, or 3x plus 2 is equal to 0. Let's add 3 to both sides of the equation. We'll have 2x is equal to 3. Divide both sides by 2. So x is equal to 3 halves. So that's going to be one of these. Let me move that up into this position over here. And then the other one, let's subtract 2 away from each side. Let's cancel this. We'll have 3x is equal to negative 2. We'll divide both sides by 3. Let's cancel this. So also x could be negative 2/3. Now for the other one, we would take the denominator and set that equal to 0, solve the resulting equation. Here it's just x is equal to 0. Now, I just want to note that my domain is the set of all x such that x is not going to be equal to this 0 guy here, okay? Because again, division by 0 is undefined. Okay, so coming to the number line, let's write this as negative 2/3. Let's say this is 0, and then let's say this is 3 halves or 1.5. So this is A, so that's less than negative 2/3. This is B, that's between negative 2/3 and 0. This is C, between 0 and 3 halves, and this is D, which is greater than 3 halves. Okay, this is a strict inequality here, so I know that this is not going to work, right? Because if you plug in a 3 halves or negative 2/3, then essentially the numerator is 0, right? The denominator is not, but the numerator is 0, so this is going to be 0 on the left side, and that's not greater than 0. So you can actually just get rid of these, and you also know that 0 is not going to work because it's going to violate the domain. So let's get rid of this. We don't need this anymore. And I'm just going to test inside of each region here. So let me write out A, B, C, and D. And we'll test inside of each. So for A, I need something that's less than negative 2/3. Let's just pick negative 1. So you have the negative of 2 times negative 1 is negative 2. And then negative 2 minus 3 is negative 5. And then here, 3 times negative 1 is negative 3. Negative 3 plus 2 is negative 1. Now you have 3 negatives. If you're just thinking about the sign, it's going to be a negative. I'm just going to write this as negative 5 just for clarity. This would be over negative 1. And negative 5 over negative 1 is 5, or you could just say it's a positive. All right, so this is 5 is greater than 0, which is going to be a true statement. All right, for B, this is a very tight window. I would just pick negative 0.5. I think that would be pretty easy to work with. So 2 times negative 0.5, that would be negative 1, and then negative 1 minus 3 would be negative 4. So you have the negative of negative 4, and then over here, 3 times negative 0.5, that's negative 1.5, and then plus 2, that's going to be 0.5 or a half. So basically, the negatives are going to cancel, right? Negative times negative is positive. 4 times a half is 2. So this is going to be 2, and this would be over your negative 0.5. Now, this is positive over negative. That's going to be a negative, and it's not greater than 0. So you can just put that this is false. If you wanted to do the division, 2 divided by negative 0.5, that's just going to be negative 4, right? So negative 4 is obviously not greater than 0. Then for C, you could pick 1. So we'd have the negative of 2 times 1 is 2, then minus 3 is negative 1. Then over here, 3 times 1 is 3, then plus 2 is 5. So basically, you get positive 5. And this is over your 1 here. So this is 5 over 1 is greater than 0, or positive is greater than 0. So this is going to be true either way you think about it. Then for D, let's just pick 2. So you'd have the negative of 2 times 2 is 4, minus 3 is going to be 1. And then over here, 3 times 2 is going to be 6. 6 plus 2 is 8. So this is going to be negative 8. So this is negative 8. And this would be over your 2. So this is negative 4. Or you could just say it's a negative. So basically a negative is not greater than 0. And obviously negative 4 is not greater than 0. So this is false. So to put everything together and get a solution, again, we know that negative 2/3, 0, and 3/2, they're all excluded. We talked about that already. So anything in interval A is going to work. So that's less than negative 2/3. So x is less than negative 2/3. Then or anything in C is going to work. So that's between 0 and 3/2. So basically I would say that x is greater than 0 and less than 3/2. Okay, in interval notation, we'll say from negative infinity up to and excluding negative 2/3. So make sure you use a parenthesis with each. Then the union with will have anything that's between 0 and 3/2. So I'll put a parenthesis next to 0 and then put a parenthesis next to 3/2. They're both excluded. So coming to the number line, I want to use a parenthesis, or again, an open circle at negative 2/3. And then I'm just going to shade everything to the left. And then over here, I want to find 0, put a parenthesis there because it's not included, and then find 3/2 as well. Put a parenthesis there because it's not included. Again, you can always use an open circle to exclude something, and then I'm just going to shade everything in between. Okay, so x can be anything that is less than negative 2/3, or x could be anything that's greater than 0, going up to and excluding 3/2. All right, let's take a look at problem number 9 now. So we have x squared minus 4x plus 4. This is over x minus 2, and this is greater than or equal to 1. Now, normally what we do is we put a single rational expression on the left. We have our inequality. In this case, it's a greater than or equal to, and then we have 0. But instead of doing that, I want you to notice that we have a perfect square trinomial up here in our numerator. So this is going to factor into x minus 2 quantity squared, or you could say x minus 2 times x minus 2. Now, why am I doing this first? Well, you'll notice that this denominator is x minus 2. So a lot of people will just go through here and just cancel this with this. And that's fine. That's what you're supposed to do. But what you have to make sure that you do is notate the domain before you do any canceling. Okay? So in the unsimplified version of this guy, x cannot be 2. Okay, if we plug in a 2, we see we get 2 minus 2, which is 0 here. This would be 0 here, and this would be 0 here, right? So 0 over 0 is undefined. So we need to note that. So you could say that x is not equal to 2 like that. I think that's a little bit cleaner. Or for completeness, I'm just going to list out the domain here. And we'll say that it's the set of all x such that x is not equal to 2. Okay, so let's think about it that way. Once we cancel this, we have x minus 2 is greater than or equal to 1. Now, solving this is just a basic linear inequality in one variable. I don't need to go through and test things or anything like that. I would just add 2 to both sides of the inequality, cancel this, and say x is greater than or equal to 3. Is this solution okay? Does it violate anything in the domain that I listed? No, because if I go to 3 on the number line, and I put a bracket there because it's included, and I shade everything to the right, I'm okay, right? This value of 2 is to the left of 3. Right, so there's no problems here. So if I wanted to list the solution for this problem, I would say that x is greater than or equal to 3. I could put a bracket here next to 3, and this would go out to positive infinity. Now, what I want to do is go back, and I want to flip the inequality symbol, and I want to show you how it's going to change things. And this is not on the practice test, but it's just for your information in case you want to know. So I'm going to go back, and I'm just going to cross this out and put a less than or equal to here. And let's just flip this and put a less than or equal to here. Okay. All the factoring is the same. The domain is the same. I can cancel this with this just like I did before. But what's going to happen is you're going to have a little bit of an issue. So let's say that now we have x minus 2 is less than or equal to 1. Let's take these to the number line. So if I solve this and I add 2 to both sides, this cancels. And I get x is less than or equal to 3. So there's a problem because if I look at 3, and for this one, I'm going to use a closed or filled in circle here. Normally I use a bracket, but for the sake of what we're going to do, I think it's a little bit better to do it this way. So x is less than or equal to 3. So normally I would fill that in or put a bracket and just shade everything to the left. But the problem is that x is not able to be equal to 2, right? Because in this form it's okay, but in the original rational expression that we had, it resulted in us having something that's undefined. So you actually have to erase this and put an open circle at 2. So let's do that and then do it like this. So you could write the solution here and say x is less than 2 or x is greater than 2 and less than or equal to 3. So this is how you would note your solution for this guy. 2 has to be excluded. If you wanted to put this in interval notation, you would basically say from negative infinity up to and excluding 2. So you need to use a parenthesis here next to each. And it's the union with, basically you would have 2 excluded, so you put the parenthesis there. And then this is out to 3, so you put the bracket next to 3 because it's included. So it's actually really important that you understand how to work this type of problem. This domain restriction is going to carry over. This is often a trick or trap question that you get on a test. So you know that 3 is included, and everything to the left of 3 is included except for 2. So that's why there's that open circle at 2, because it is excluded. All right, let's take a look at problem number 10. So we have x plus 6 over x squared minus 5x minus 24. And this is greater than or equal to 0. So I'm going to just write x plus 6 over here. And then down here, I'm going to factor this. So give me 2 integers whose sum is negative 5 and whose product is negative 24. So that's going to be negative 8 and positive 3. So x minus 8, that quantity times the quantity x plus 3. And then this is greater than or equal to 0. So again, I'm going to say that x plus 6 is equal to 0. That's for my numerator. So here, we'll just say that x is equal to negative 6. Again, just subtract 6 away from each side. Then for the denominator, if we set that equal to 0, well, x minus 8 would be equal to 0. So then x is equal to positive 8. Then x plus 3 would be set equal to 0. And then x would be equal to negative 3. Okay, so again, I'm just going to list the domain here, just so it's clear. So we know that x can't be 8 because 8 minus 8 would be 0. We'd be dividing by 0. That's undefined. So the set of all x such that x is not equal to 8. And then also it can't be negative 3 for the same reason. Okay, so for negative 6, that's going to be right there. And then you have negative 3, so that's going to be right there. And then you're going to have 8, which is right there. Okay, so this is A, so that's less than negative 6. This is B, between negative 6 and negative 3. This is C, between negative 3 and 8. And this is D, which is greater than 8. All right, so let me write that out. So A, B, C, and D. Let's put this like this. So for A, I would just pick something like maybe negative 7. So again, just think about the sign. So negative 7 plus 6 is going to be negative 1. So you could just put negative there, or if you want to put negative 1, that's fine. This would be over. You have negative 7 minus 8, which is negative 15. So this is a negative. And then negative 7 plus 3 is going to be negative 4. So this is a negative. So basically, you'd have a negative over a positive, which is negative. Now, a negative is not greater than 0. So this would be false. Okay, for B, let's use negative 5. So negative 5 plus 6 is 1. So let's say this is positive. And then for negative 5 minus 8, that's going to be negative 13. So this is negative. And then for negative 5 plus 3, that's going to be negative 2. So this is negative. So this is positive over positive, right? Negative times negative is positive. So positive over positive is positive, and a positive is greater than 0. So this is true. Okay, for C, let's pick 0. So you get 6, which is positive, over negative 8 times 3. So it's negative 24, but let's just say it's negative. Positive over negative is negative. Negative is not greater than 0. So this is false. Okay, for D, let's pick 9. 9 plus 6 is 15, so this is positive. Then 9 minus 8 is 1, so that's a positive. And then 9 plus 3 is 12, so that's a positive. So basically, positive over positive is positive, and a positive is greater than 0, so this is true. Okay, now in terms of the critical values, this guy right here, this x equals negative 6, again, that makes this whole thing 0, right? Because it makes the numerator 0, the denominator wouldn't be 0. So 0 divided by something that's not 0 is 0, and 0 is going to be equal to 0, right? So the or equal to, this is non-strict. So this is going to satisfy this guy. So we know that negative 6 would be part of the solution, but then 8 and negative 3 would not be. For interval B, we have from negative 6 up to and excluding negative 3. So we're going to say that x is greater than or equal to negative 6, again, that's included, and less than negative 3, again, that's excluded, because it makes the denominator here 0. Then we would say, or we can have anything that's greater than 8. So we'll say x is greater than 8, and again, that's excluded because it would make the denominator 0. Okay, so negative 6 is included, so I'm putting a bracket next to that, and then we're going up to and excluding negative 3. So you want a parenthesis with that. Then it's the union with, so it's anything larger than 8, so it's excluded, so make sure you use a parenthesis. So graphically, let me put a bracket at negative 6, or again, you can use a filled-in circle. Let me put a parenthesis at negative 3, or you can use an open circle, shade everything in between. And then at 8, let me use a parenthesis there, or again, you can use an open circle, and then just shade everything to the right. So x could be -6, or any number going up to but excluding -3, or x could be anything that is greater than 8.